A lot of things can go wrong when you're 3D printing, and it's easy to understand why. I mean, you're melting, cooling, and then extruding plastic on top of other melted and cooled plastic. It's got to be at the right temperature to extrude. It's got to be extruded at the right rate. And the heater that's doing all this is hovering over the plastic that's already been extruded. So you have to have sufficient cooling, and then if retraction isn't set right, it gets complicated. So when something does go wrong, when, not if, I like to use an approach that I call the limits of one. Let me give you a little background. In a past life, I worked for a large manufacturing company that specialized in molding thermoplastics and thermosets, and then assembling those parts. And one of my responsibilities was to manage all the physical equipment, which included injection molding machines, transfer presses, automatic paint booths, and assembly line cells. And it was my job to make sure that the output of those lines was optimal. And as it is in most manufacturing plants, there was always something going wrong, always a problem to be solved. And after being there for over 6 years, I got pretty good at solving problems. The method that I almost always used is what I now call the limits of one. I would first identify all the factors that could possibly influence the outcome of the current problem. And then one by one, I would adjust just one setting to its upper limit until it produced a bad result, and then to its lower limit until it produced a bad result. That would tell me the limits of that particular setting for the problem that I was addressing. And if that didn't solve the problem, then I'd move on to the next setting and do the same thing there. And at the end of that process, I knew a whole lot more about what is needed to get a desired result. For example, I love soft-boiled eggs. They're like hard-boiled eggs, but the yolk is soft. So if I wanted to make the perfect soft-boiled egg, where the yolk is gooey and the whites are tender and it peels easily, I'd first identify all the factors that influence what's most important to me in a soft-boiled egg, which is the doneness of the yolk. And while there are a ton of ways to cook an egg, if you really think about what doneness depends on, it would be temperature and time at that temperature. Now, you could break temperature down into lots of different factors. Temperature before cooking, are my eggs at room temperature or straight out of the refrigerator? Temperature while cooking, do I put the eggs in cold water and then put it on the stove, or do I put them directly into hot water? Temperature after cooking, do I turn off the heat and leave the eggs in hot water? Do I simply take them out of the hot water? Or do I take them out of the hot water and put them in an ice bath? So there are a lot of different ways to go about cooking the perfect soft-boiled egg. But ultimately, it boils down to, It boils down to the internal temperature of the egg and how long it's held at that temperature. Now, I know this is an oversimplification of processing out manufacturing problems, but it gets the point across. And the point is, I'm not going to change 2 or 3 variables and then observe the result. I'm not going to hold the water at 200 degrees Fahrenheit and then put the eggs into an ice bath for one experiment. And then for the next one, put the eggs in 180 degrees Fahrenheit water and no ice bath afterwards. Because if I get a good result, then I won't know which factor led to it. Just as a side note, using this approach, I might find a good combination of steps that gets me the perfect soft-boiled egg. And it may be completely different than the steps that my aunt takes to make the perfect soft-boiled egg. But at least we both have perfect soft-boiled eggs. Isn't that the point? So to see this process in action, stay tuned for my next video where I'll show you how I use this technique to dial in my slicer settings for every new filament that I buy. Okay? We'll talk soon.